Here's an example sequence diagram for a soda vending machine. In this diagram, blue represents physical objects, not computers, and black is microcontrollers with software, although that is a non-standard notation. Pre means precondition, post means postcondition, and other ovals are side effects. This sequence diagram is only eligible to execute with the precondition that the coin control controller thinks that there are 2 coins already in the soda machine. Nothing happens until the customer on arc 1A presses coin return. Therefore, for this sequence diagram to trigger, the preconditions have to be true and the first arc has to occur, which is pressing the coin return. The coin return button itself sends a pulse to the coin control, which dispenses 2 coins, the first one, 2A, 2B, which has a side effect of saying, all right, I used to have 2, I have 1 fewer coins now. After the side effect, coin control tells the vend control, by the way, I only have 1 coin now because vend control keeps track of what the price of things is. Coin control dispenses the second coin, reduces coin count again, and at the end, because you started with 2 coins and coin count has been reduced twice, the post condition is guaranteed to be that there are no coins left. And the vend control has been told this, as well as the coins actually being returned to the customer. There are other objects in this system, but they're omitted from the diagram because they do not participate in this particular interaction. Summing up, a sequence diagram has a set of objects, some preconditions, some interactions and side effects, and a postcondition, with that sequence diagram showing one possible way to execute a use case within a system.